Algebra 2 notes 7-2 graph exponential decay functions. So when we look at exponential decay functions, our exponential functions are still in that same form. Y equals a times b raised to the x power. So remember, our x is our exponent. But now when we have an exponential decay function, it's because a is greater than 0 and b is between 0 and 1. So basically, like b could be 1/2. So it's kind of like you're multiplying something by 1/2 each time. So that's going to give us decay. So this part makes it decay. And this is our exponential function. And the decay factor itself is b. So this is really similar to 7.1. When we look at our general shape now, and we look at our x and y, and again, we're looking at y equals b to the x power, just like we did for 7.1. Now, because b is a fraction, I know, I know when x is 0, y is always 1. But because b is considered a fraction, b is between 0 and 1. So by fraction, I mean like 1/2 or 1/3, something between 0 and 1. When x is 1, y is going to be b, but b is going to be a smaller number. So I have 0, 1 right here, and then b is going to be between 0 and 1. And so my graph is going to go like this now. So the graph is going to fall from left to right. And it's possible to have a graph that falls from left to right that's not decay. So be really careful. Just because a graph looks like this doesn't mean it's decay. B has to be between 0 and 1. And then A needs to be positive. And now we're looking at also, again, the x-axis, or y equals 0, is still an asymptote. Our domain is still all real numbers. And our range for decay functions is still that y is greater than 0. So just basic same stuff for exponential functions. So here's an example. We're looking at 1/5 raised to the x power. So I'm going to make my table again. I always use -2, -1, 0, 1, 2, just because of the symmetrical aspect of it. Even if I can't graph all the points, I just graph what I can. So -2 power, if I raise 1/5 to the -2 power, that means I need to flip the fraction and I need to square it. So this will be 25. To the -1 power, I'll just flip it, so I'll have 5. 0 power is always 1. This will be 1/5 and 1/25. So now I'm going to go ahead and graph, and obviously I'm only going to graph those middle 3 points. So when x is -1, y is 5, 0 is 1, 1 is 1/5, and function looks something like this. So again, we are not actually reaching 0, we have an asymptote there. Now we've got one that's being multiplied by a coefficient. So remember, if we multiply by 3, that's a vertical stretch by 3. And when I build a table for these, I'm going to use the same values for x, -2, -1, 0, 1, 2. And then first I'll look at 2/3 being raised to that power. And this is kind of that middle row that I'm using for work, but I'm not actually graphing. And then I'll figure out 3 times the 2/3 x. So -2 means I'm going to have to flip my fraction and square it. So 9/4. Negative first power, we'll just flip it. 0 power is 1. First power is 2/3. And then squared will be 4/9. It might be easier to do 0 first and second power, and then just know that those first two are reciprocals. So you could do it that way as well. Now I have to multiply them all by 3. Remember, it's 3 over 1. So this would be 27/4, 9/2, 3, 2, and 4/3. So now I'm going to graph what I can. Let's see, 27/4 forward divide into 27, not quite 7 times. So I'd have 6 3/4. So let's see, -2, 1, 2, 3, 4, 5, 6, almost to 7. 9 halves is 4.5, so -1 up 1, 2, 3, 4.5. 0 is 3. 1 is 2. And 2 is 4/3. Graph should look something like this. So we do have exponential decay again. We have decay because 2/3 is between 0 and 1. And A is, again, 3 is greater than 0. Greater than 0. So on this one, I do have something between 0 and 1, but this is not greater than 0. So this is not going to be exponential decay. And it's not exponential growth either. So it's possible that you can get functions that are neither one of those things. So when I graph, I'm going to start out with x. And then we will raise 3/4 to that power. And then our last part on our table will be -2 times 3/4 to the x power. And remember, when we're graphing, we're not graphing this middle row. We're just graphing the values that we can from the first row and the last row. This is my x. This is really my y. The middle row is just to help me figure this out. So I'm going to start over here with the squared one this time. So this will be 9/16, 3/4, 1. And then I'm going to do reciprocals, 4/3, 16/9. And now I have to multiply everything by -2. So this should be -32/9, -8/3, -2, -3/2, and -9/8. Lots of fraction work here. So 9 divides into 32. Let's see, 9 times 3 is 27. So like maybe 3.5, somewhere around there. This isn't super accurate when we graph, so I just worry about what it's between. I don't worry about making it super accurate. So -2, and then between 3 and 4. -8/3, that's -2 and 1/3. 0 is -2. 1 is -3/2, and then -9/8. So again, it doesn't look like exponential growth or decay, and it's not exponential growth or decay. So going on to the next page, we're looking at translations again. And so if it says x minus 2, that's going to be 2 units up. And if it says a +1 over here, oh, sorry, that is completely wrong. Let me fix that. When we're talking about x, we're talking about right or left. So this one is going to be 2 units to the right. -2 means it's really going to do the opposite. And then this number out here is kind of like my y-intercept, so it's going to move it 1 up. So when I make a table, I am going to make a table for just the 2 times 1/3 x, which is my y. So again, we're not actually graphing that middle row. And then I'm going to translate it. So let's go ahead and do this middle row. Squared would be 1/9. First power would be 1/3. 0 power is 1, and then reciprocals. And now we're going to multiply those by 2. So I'm taking all the middle row, and now I'm doing 2 times by 1/3 x. And then really, I'm only able to fit on my graph probably these points, right? So -1/6, 0, 2, 1 2/3. I'm just trying to make really clear what I'm graphing. So -1 is 6, 0 is 2, 1 is 2/3. But now I have to translate all those points. So they're all going to go 2 units to the right and 1 unit up. 2 units to the right, 1 unit up. And because I have moved my graph 1 unit up, now my asymptote will be at y equals 1. And so the graph should look like this. Exponential decay model. So we looked at a growth model yesterday. Today we're going to look at, or actually earlier today, depending on if we have doubled up lessons, what pace we're working at this year. So instead of 1 plus r, now it is 1 minus r. And y is the amount after t years. A is our initial amount. R is our percent decrease. And remember, we always do this as a decimal. And 1 minus r is the decay factor. So we are looking at an example here where they're talking about a new car decreasing in value. So depreciation of a car is a great example for this. So our initial amount would be that 25,000, decreasing by 15% each year would be R. So we're going to just write our initial model using this. So we'll have 25,000 times 1 minus that rate as a decimal, 0.015. And then this is for however many years we want to check it for. So I'm going to go ahead and simplify this by subtracting. So that would give us 25,000 times 0.085 raised to the t power. And now we're going to use that model to find out the value of the car after 4 years. So I'm going to substitute 4 in for t. And then this is now calculator ready form. And when I plug this into my calculator, I want to make sure to keep 2 decimal places because we're dealing with money. So this is what I got on my calculator, $13,050.16. This is the end of our 7.2 notes. Please let us know if you have any questions.